Hey everyone, this video is to go a little bit more in depth with the least common denominators that we need to find when we are adding or subtracting rational expressions. So the least common denominator is the lowest common multiple of the denominators of a set of fractions. Another way you're going to hear me describe this as the smallest thing that both denominators can divide into. You can find many common denominators. The least common denominator, though, is always going to give you the least amount of work. So for the least common denominator, I'm only focusing on the denominators of each of my fractions. So the first thing that we always want to do is we want to make sure that we're factoring our denominators so we can figure out exactly what needs to go into each of these. So if I focus on 4x squared minus 12x, in order to factor that, I'm going to take out a GCF of 4x, which is going to leave me with x minus 3. And my denominator on the right, 8 times x to the fourth just stays the same because that can't be factored. As for determining the LCD, the easiest place to start is always by the coefficients and then any monomials that you might have. So 4x times x minus 3, I have a coefficient of 4. And the one on the right, I have a coefficient of 8. The smallest number that both 4 and 8 divide into is going to be 8. So we need that in our LCD. From there, I go and I focus on my powers of x. I have x and I have x to the fourth, which is really x times x times x times x. Well, in order for both of them to divide into it, you want to focus on your biggest power, your biggest exponent. That's what you have to go up to for your LCD. So 8x to the fourth. And then if there's any other factors here, x plus or minus number, that also has to be included in your LCD. So that takes care of our x minus 3 that's over here on the left. Now, a really great, easy way that you can check and make sure this works out is to take the LCD and divide both of your denominators into it. This is also going to help you identify what exactly you need to be multiplying by. So in the fraction on the left, I can eliminate the x minus 3. 8 over 4, that's going to reduce down to just 2 in the numerator. And then the x in the denominator cancels, and the x to the fourth becomes x to the third. If when you're doing this, not everything cancels in the denominator, that should be a huge red flag. What we're left with here is 2x cubed, which when I'm actually solving these problems, I take whatever I'm left with, and that's what I'm going to be multiplying numerator and denominator by, the 2x cubed. And then on the right, 8 will eliminate with 8, x to the fourth will eliminate with x to the fourth, and you're left with x minus 3. This x minus 3 is what the fraction on the right needs to be multiplied by, numerator and denominator. So doing this stage of putting the denominator underneath the LCD is super helpful because when you do this, not only are you able to see that both things divide into it, but you're also able to identify what exactly you should be multiplying by to get your LCD. Now, in the second one, I see a lot of people that when they see this, they want to treat the w and the 1 as separate things and the w and the -7 as separate things. and they like to say that the first fraction is missing a -7 and the second fraction is missing a +1. Anytime you have this, you need to think of these as factors, which means the LCD needs to contain every single factor. I have a factor of w plus 1, that needs to be in my LCD. I have a factor of w minus 7, that also needs to be in my LCD. And then like we did in the previous example, I'm going to take my LCD and I'm going to divide each denominator by it to see if it actually eliminates. So I take the first one, put it over w plus 1. I take the LCD again, and I put it over w minus 7. And what we notice in the one on the left, w plus 1 cancels out. You're left with w minus 7, which is what you should be multiplying numerator and denominator by in the fraction on the left. In the fraction on the right, w minus 7 cancels out. You're left with w plus 1, which is what you would multiply the numerator and denominator of the fraction on the right by. If you want to see examples of how to actually finish these problems and add or subtract them, there are 2 other videos posted on YouTube to look back at. And lastly, when I look at my first denominator, this x squared minus 4, that can factor because those are both perfect squares, so we have the difference of 2 squares. It factors as x plus 2 times x minus 2. And my fraction on the right just has an x minus 2. So for determining my LCD, the nice thing here is you only have easy binomial factors. You don't have any coefficients. You don't have any powers of x. So what I tend to do is I focus on the one on the left, and I just rewrite it. That's x plus 2 times x minus 2. And then I go to the one on the right to see if it has anything that the first one doesn't. It has an x minus 2. Since that's already in the LCD, we don't need to worry about putting that on for a second time. So what we're going to do from here, I'm taking my LCD and I'm dividing it by both of my denominators. Little mistake on that. The second denominator should only have the x minus 2. So what you notice when looking at the one on the right is the x plus 2 and the x minus 2 both eliminate. You're left with 1. It's not necessary to multiply a fraction by 1 because it's not going to be changing. So this fraction on the left actually does not need to get multiplied by anything. The fraction on the right, I can eliminate x minus 2, and you're left with x plus 2, which tells you that the second fraction needs to get multiplied by x plus 2 over x plus 2 to get your common denominator.